Let's start by taking a look at some essential concepts of modeling processes, dealing with information flows, performing business and process analytics, and then identifying opportunities for process automation and robotic process automation. So when you think about modeling information flows in an organization, there is a couple of different approaches that are often taken. One is to model the data or the information as it flows through an organization, as it flows through various processing stages. That's often referred to as data flow modeling, and it is most commonly represented as data flow diagrams, or DFDs. The more modern approach to modeling information flows is to model the activities that process information and then show the sequence of those information processing activities. That's often done using models and visualizations like flowcharts. There are some other models in use as well. One of them is the context diagram that often used to show process or system inputs and outputs, but doesn't really focus on the flow. We're not going to worry about those. We're going to work primarily about modeling activities via flowcharts. Now, when you model a process, there is an overarching goal. The overarching goal of business process modeling and business process design is to improve the execution of a process and to make it more efficient, typically in terms of cost and or time. Have it take fewer resources, have it be shorter, have it be more efficient, maybe have less rework. There's a number of different potential improvement goals that one might have, but it always involves some improvement to the organization. Now, of course, if you want to build an information system or systems that support an organization, you need to know where in a business process the information system contributes. Maybe it automates some step, maybe it verifies the work done in some step, but there is always some kind of an integration that the system has with the process that it's trying to automate. Now, modeling a process is your first step because it helps you identify where there are potential areas of automation. Now, when you look at the overarching flow of business process management, it starts by first eliciting the process. That means you figure out who does the work, what the work is, what the individual activities are, if there are decisions that are being made by somebody along the way, what those decision outcomes could be, how they affect the flow, whether certain activities are done concurrently or in parallel, whether data gets or information gets handed off from one party to another and how that gets done. But there's a lot of elicitation work involved. Once you're done with elicitation, you model the process. Now, that could mean in the simplest form that you write a process description. You write a narrative. But more likely, you are going to build a flowchart, a visualization of that process. Now, once you have that process model, then you can analyze it. You can look to see if there's maybe redundancy, if there are activities which take much longer than they should or need to, whether there is an area where you can automate certain activities that are being done manually now. You analyze, you figure out where you have weaknesses, you redesign the process. And then, hopefully, ultimately, as you redesign it, you identify portions or perhaps entire processes which can be fully automated. Modeling a process is also often called modeling a workflow. And the reason why it's called a workflow is because you're modeling the way that work flows through the organization and the way data moves from one stage of processing to another. And essentially, a workflow model is the visualization of the distribution of processes across responsible parties. And if you want to get very detailed and very direct, a process model simply shows what work gets done. A workflow model also shows who does the work. Now, if you work in different organizations, you might also hear alternative terms like a process map, or a flow chart, or a swim lane diagram. But in all cases, they really are doing the same thing. They build some kind of a graphical depiction of work that gets done in an organization. Now, the reason why organizations do this is pretty simple. It helps them document a business or some other process. So, for example, if you're thinking about an example at Northeastern, the grade change process. It's a fairly complicated process involving lots of parties, collection of lots of information, and transmission of information to various parties. But the process is very simple. The event is a student or an instructor identifies a mistake in a grade. It initiates a change of a student's grade. So there is a trigger that triggers an activity or a set of activities, and then there is an amount of work that gets done. First step is that the instructor obtains a change of grade form. The instructor then completes the form by filling in the student's name, student's NUID, the course number, the course title, the CRN of that course, the term in which it was taught, the student's current grade, intended future grade, a reason for the grade change, and so on. So there's information collection that occurs. The form again needs to be sent by the instructor to the dean's office for the instructor's college. They have to review it, and more until eventually, of course, it ends up with a grade change in the student's transcript. But in that particular case, the reason why you might build a model is because you want to document the process. I've done that because I often wanted to teach new instructors how a grade change works. And so it was a way for me as a mentor or a director, I wanted to communicate a particular process to new instructors. So in that case, it was purely a documentation reason for the process. Now, I might also look at it from an administrative perspective, and I might use it to identify weaknesses in the process. Places where there is work done redundantly, where there's work done that really is necessary, where maybe work is done that could be split up and done in parallel by two separate people and thus make the process faster. Now, by building a new and improved process model, I can then evaluate improvements. It could say, well, geez, this is the current process. Here are some of the weaknesses that we've observed or that we've identified. Here's an improved process. What does everybody think? I can then use that to communicate my business logic to my stakeholders, fellow instructors, deans, the registrar's office, the provost's office, and so on. I might even use that process model to help me automate the entire grade change process, or at least certain parts of it. Sometimes you don't have to necessarily automate an entire process. You might just choose to automate some part of a process. It's also useful because it allows you to gain consensus among the stakeholders. So maybe if you are discussing a new and improved grade change process with deans in various colleges, maybe with multiple faculty members, with the registrar, well, if you just simply are talking about it, it's kind of hard to know whether everybody really views the process the same way. So building a process model, a graphical depiction of the process, means that everybody is working from the same blueprint. They're all discussing the same process. Now, like I said, the next to last one here is facilitating the onboarding of new employees was one of my reasons why I originally documented the change, the grade change process, because I had new faculty coming on board and they needed to know how to change a grade. And I got kind of tired as we hired more and more people to keep having to explain it term after term. In some industries, there's also regulatory compliance need. There are some industries like insurance, certain finance industries, certain life science industries where you have to document certain processes because of compliance reasons and because of regulations. The thing is that if you don't have a process documented and it's not accessible and the employees aren't trained, if the regulatory body like the FDA audits your organization and finds that you are not documenting your processes properly and you're not teaching and training your employees to follow them, then you could be deemed to be out of compliance and potentially fined. So these are some of the reasons why organizations build process models. When you actually go to building a process model, you have to decide what your perspective is for the process model. And we can build process models from two perspectives: current state, or the as-is state, and future state, or the to-be state. So if I were to go build a process model of the current and a currently practiced and implemented great change process at Northeastern, I would build a current state model. That means I depict the process the way it's done right now. Doesn't matter if I consider it to be flawed, it doesn't matter if there is problems, doesn't matter if it's inefficient. I'm documenting what is done right now. I'm building a current state model. And then it can use that to identify areas for improvement, make my improvements, and build a new model that represents the process as I want it to be. So that's my future state process. You never want to mix the two. So if you have a current state and you want to improve it, if a future state, you would have two diagrams. By the way, one of the nice things you can do with tools is to often have what we call layers or multiple types of overlays, where you can actually have an existing process in one diagram on one layer, and then you can have a new process on a different layer. You can actually overlay one over the other, so you can see the differences between the two. Maybe use different colors to really draw out where an existing process is changed. It's very helpful because it allows you to figure out if a process changes somewhere but not everywhere, who you have to alert of that change, and which of your employees might have to be retrained. Because it might not necessarily affect the entire organization, it might just affect some parts of the organization. But bottom line is, you have to build your process models from a perspective, and when you build your eventually diagrams, you have to mark them with your perspective, whether this is depicting a current state or a future state process. Now, when you do this in practice, one thing to keep in mind is that not all problems with a process are causing big problems. Most process issues are caused by a relatively small number of process defects. Now, there is an analysis technique that's often referred to as Pareto analysis. It's named after an Italian, I think it was statistician, Wilfredo Pareto. He discovered that there is often in nature an unequal distribution of things. Now, he, I think, originally found that 20% of olive plants produce 80% of the olives in most yards. He also found that the majority of real estate was owned by a very, very small number of people. So there's not a uniform distribution, but there's always a distribution that tends to concentrate a very large amount in a very small set of owners. And the same is true a lot in systems design and information systems analysis and information modeling, that a very small number, for example, of process defects cause a lot of the discontent or a lot of the problems with an existing process. So the idea behind Pareto analysis is to identify what your issues are, identify those small number of issues which are causing the majority of the problem, and fix those first. So instead of trying to fix every issue, fix the ones that are causing most of the problems. And often by solving 2-3 problems, you fix the vast majority of the complaints with a process. Now, as you make changes to your process, you should follow the scientific method. That means you should identify what changes you believe ought to be made and what you believe are the consequences or the improvements. Now, you got to gather data and measure what your current state is. So if you believe you have certain problems, let's say with the grade change process, you have problems with grade changes getting lost, grade changes not being made in a timely fashion, whatever the problems are, gather them. Figure out how many grades are entered by mistake per term or per year. How many missed grade changes happen each term. Whatever the metrics are by which you measure based on the complaints you're getting from faculty, students, registrar, provost, alumni, and so on. Then, if it's a very complex process, it could potentially be very disruptive, you build a simulation of that process. Now, this happens a lot in manufacturing where rebuilding a process, a manufacturing process, might involve building factories, might involve building large buildings and industrial grade and industrial size type of machinery. That's not happening overnight, and it's also very expensive. So you often might want to build a simulation of the new process first and try it out, see if it truly makes a difference. Now, for us in information systems world, often we can try new processes on sandboxes and sandbox systems, try them out, and then of course we gather new data. We see if the new, for example, grade change process has been in place for a while. Does it reduce the number of grade changes? Does it eliminate errors? And then see if that improvement was statistically significant. And if it was, great. Leave it. You've done a good job. Now, of course, if the effect was not any better, either in your simulation or in your sandbox approach or when you rolled it out, consider rolling it back, undoing it. Because you might actually have done more harm with it now, and of course if it's not implemented yet, if you do implement it, but the change really doesn't have an effect, then why bother building systems, retraining people if it's not going to have an effect? Now, of course, if it didn't work, formulate a new hypothesis, figure out a new potential change, and go test it again. Also be prepared that every time you make a change to a process, it's like making a change to any type of complex system. There could be side effects with unintended consequences. So always be on the lookout after the change is made, whether there are unintended consequences, things that are now different, maybe new problems you've introduced that you did not anticipate. And if the side effects are not acceptable, roll back the changes. Or you might decide, well, it's not perfect, but it's better than before. Well, then worry about fixing or improving the process to eliminate the side effects. So at an enterprise level, this often means that there is a spectrum of process innovation. Most of the time you make small, continuous improvements to existing processes. You update a form, you update a system, you automate some part of it. They're small incremental innovations, and over time, over the course of months or years, the organization gets better and better, more and more efficient, more and more effective. Sometimes you might find that new technology comes out, or there are other types of big innovations that allow you to do work differently. In that case, you might fundamentally change some activity or part of a process. Example would be the advent of tablets. It means that suddenly people can sign documents electronically. So maybe instead of having to have a paper form, you would have an opportunity to automate that through some kind of a tablet-based app. That's an architectural innovation. And then, of course, there is potentially some kind of a radical advance, societal change, and economic change that completely changes the way things are done. Some kind of a discontinuous innovation that completely changes the way work is done. Example would be things like Uber, where there was a fundamental change to the way that individuals procure transportation, which completely disrupted, for example, the taxi industry. Now, those don't happen as often, but when they do, of course, that means that suddenly your processes are completely different because your industry no longer exists in the same fashion that it did before. So that's a quick overview of some of the key concepts in business process analysis and business process design. So again, some of the key observations are that, one, articulating business processes and visualizing them are a necessary precursor to any type of automation and improvement. Process models have to be constructed following a methodology. They have to be done in a methodical manner, and they're presented in a standard notation. Pareto analysis can help you identify quick wins. That means small improvements that can have big effects and eliminate a lot of complaints about a process. But process improvement should nevertheless follow the scientific method, where you formulate a hypothesis, where you believe the change and the improvement would be. You simulate, implement in a sandbox, or implement in the wild. You measure before, you measure after, you see if it had an actual effect.